In our guess the number program we updated last time, we called the guess procedure twice, which is fine. But what if we had to call it 5 times? Or even 100 times? That would be horrendous. We could easily make an error here. But there's a solution, called for next loop. Like if, else, and if, a for statement comes in pairs. And like if, else, and if, you can break up a for next statement. A for next statement is a remarkable piece of software engineering. Let's begin with the for statement. The for statement pairs with a variable, any variable, and assigns it with a start value. Then the to keyword establishes the limit. And finally it remembers the next statement, because that is where it returns to when it encounters next. The next keyword will do 2 things. First, it will increment the variable by 1. Second, it will check if the limit has exceeded. If it has, it will simply continue to the next statement. If it hasn't, it will resume execution after the for statement. Before it starts executing, for does one more remarkable thing. Let's assume we start with an initial 5 and set the limit to 1. For will see that the limit has already been reached and will resume execution after the next statement. Now you say, what does next do with the variable x after the loop has been terminated? As a matter of fact, nothing. Let's say we start with the value 5 and set the limit to 10. When it has reached 10, next will increment it and see it has exceeded the limit. So it doesn't loop. But x will still hold 11. Now let's see how that works out. Remember those pesky multiplication tables you had to recite? Well, with the for next statement it is easy to recreate those. We start by defining which tables we want to generate. Let's say from 2 to 10. So our for statement reads for t is 2 to 10. And let's add a next statement for good measure. Oops, we forgot the end, bad idea. Now let's define a procedure that prints a single table. Let's call that one make table. I don't know how your tables were laid out, but ours went from 1 to 10. Note we can't choose the variable t again, because that one was already associated with the former for next. So let's take m. Yeah, you guessed right, our for next loop now looks like for m equals 1 to 10. You're getting a feel for it? Okay, let's not forget that next. Now let's print our table. Of course we need a print and then our multiplication value. Let's add an x. Now our table, that's t, an equal sign, and finally our multiplication. That's it, we're done. Let's run it. Okay, that's a bit confusing. Let's give our individual tables a bit more vertical space by separating them with an empty print. That looks much better, huh? You can also nest the loops, by the way. And then it looks like this. And note the indentation. The inner for belongs to the inner next. And the outer for belongs to the outer next. So what does that mean for our program? We can replace 2 procs by embedding a single one of them in the for next loop. Done. And that's a wrap. So what have we learned? Using for next, we can execute a block of code for a specific number of times. Like if else then, for and next have to be defined in pairs. And no, you cannot split them up. If you want your for and next to be compact, think procedures. We covered that last time. The for statement binds a variable. You cannot use that same variable in for next loop that are concurrently executing. You will mess things up pretty badly if you try. And after binding it, for sets that variable to a specific value, the starting value. The to statement sets the limit. If that limit is exceeded, the loop will be terminated at the next time next is encountered. Note that if you choose some crazy values for your starting value and your limit, for will not play along. It will not execute anything until after next. The next statement will first add 1 to the value of the variable. If the result exceeds the limit, the code after next will be executed. If the result is within the limit, it will continue the execution after the previous for statement. And note that the bound variable will keep its value even after the loop has been terminated. So, obviously it will have a value then that exceeds the limit. And that's the end of the line, folks.